This is lesson 19, which is dividing polynomials. So 19.1 starts off with dividing polynomials by inspection, which kind of means like to make sure that things are factored fully and then we can cancel out common factors. So if we look at more of like a basic example, like without kind of polynomials, without variables and stuff like that, inspection would be like if I asked you to reduce the fraction 24 over 36. There's a ton of different ways to reduce this fraction, but one of them is by like thinking of the common factors of those two numbers. So for example, 24 is 12 times 2, and then 36 is 12 times 3. So now I can take like the two 12s, and 12 divided by 12 is 1, so those would wipe each other out, and I would just be left with 2/3. So that's kind of what inspection is. We just do it with polynomials by like factoring if the problem is not already factored. So 19.1, example 1. Find the quotient, so 36x cubed divided by 6x squared plus 12x. So the first step is if a problem is not already written as like a fraction, we kind of want to rewrite it like that because fractions are just dividing. So first of all, it's always the like number, like the first number, like the one that we're dividing into that goes in the numerator. So it'd be 36x to the third power in the numerator. And then what we're dividing by goes in the denominator. So it'd be 6x squared plus 12x. And then in the like previous example, like the 24 over 36, we had to list the like factors, or we had to find some common factors of 24 and 36. So we're going to do the same thing with example 1. We just have to make sure that everything is factored. So 36x cubed, that's just like the one term, so there's nothing to factor there. But in the denominator, there's like the 6x squared and the 12x, so we do want to factor that part of it. So I'm just going to copy over the 36x cubed, and then from 6x squared plus 12x, I can check for greatest common factor. So both the coefficients 6 and 12 are divisible by 6, so I can factor out a 6. And then for the x's, there's a x squared and x to the first power. So if there's like multiple variables, we can definitely factor out an x, but we can only pull out the lowest one that they both have in common. So I could pull out an x to the first power. And when I factor out GCF, it's like doing the same thing as, or not the same thing, but like the reverse of distributing something in. So I would still have some stuff left over inside the parentheses. It'd be whatever I have left after I take that 6x and divide it out of both terms. So if I do 6x squared divided by 6x, that would leave me with just a 1x. And then, of course, I don't have to write the 1. And then 12x divided by the 6x would leave me with just 2, positive 2. The x's would cancel out. Okay, so now the denominator is factored completely. There's really nothing else for me to do. Like the x plus 2 can't be factored any further. So it's factored fully. So now we can begin to look for common factors to where we can actually kind of like reduce this fraction now. So set up my fraction bar, and then I can look at what my coefficients are. I have a 36 and a 6, so I can definitely reduce those. 36 divided by 6, that would just become 6, or you think if I divide these both by 6, this would become a 1. 36 divided by 6 would become a 6, so I still have a 6 left in the numerator. And then one of my other factors is an x. So I know that like x cubed and x to the first power, they look like two different kind of things, but they're both the same factor. They're both x's. It's just one is being raised to a higher power, but it's kind of like the same base. So if I have an x to the first power in the denominator and an x to the third power in the numerator, that x to the first power cancels out one of the three, so I would have two left. Okay, so this one cancels out. This one goes down by 1 power, so it would go down to like x squared. It goes down by 1 power because this was an x to the first power. So then in the numerator, I have x squared left over. And then I still have this x plus 2. There's nothing more for me to carry out or like kind of cancel out or anything like that. So I would just copy it over x plus 2. Okay, and then now it can be like really, really tempting to cross off like another x like right here and right here, but we technically can't because the x in the denominator is no longer a factor. A factor is something that's being multiplied. The only like entire like factor we could consider in the denominator would be this whole thing. So the only way to get rid of that whole thing would be if I had the same exact factor up here, like another x plus 2 to cancel out with it. So this one was okay to cancel out because it was a factor of something that was multiplied, versus this is just an individual term. It's something that's being added, so we can't cancel out individual terms. Okay, so final answer should be 6x squared plus 2, or sorry, over x plus 2. Okay, and then for example 2, find the quotient. So this one is already set up as kind of like a fraction, but nothing in this problem is factored yet. So it's really important that we always have to remember to factor if something is not already factored, because it can be so tempting to just be like, I can cross off these x's or I can cross off these x's. But that's not the case because those x's are a part of like a term, and we can't factor any, or sorry, we can't cancel anything out until we have like factors. So essentially, like if we tried to cross out x's as like terms, like kind of as it's written in this problem, it would be the same thing as like trying to reduce a fraction by divide or by like subtracting out a common number. So like say I were to take like both of these, you would never like subtract 2 from both. And then this would become like 1 over 3, which these are not the same value in any way. That's why we can't reduce fractions that way. You always have to reduce fractions by dividing by a common number, which is exactly why we have to like get these polynomials factored, because that's the only way to figure out what we can kind of like divide out from each like numerator and denominator. Okay, so example 2, it's 3x squared minus 3x minus 36 over x squared plus 12x plus 27. I don't know if I said this wrong. I might have said it weird. Feels like I said it weird in my head, but 3x squared minus 3x minus 36. So we got to make sure everything's factorable. When we're factoring, we always want to check for greatest common factor first, which is just like a common factor that each term has. So in the numerator, all the coefficients are 3s, so I can definitely factor out a 3. I'm just going to go ahead and write it above just to kind of save ourselves like a line. And then when I factor out the 3, that's like doing the reverse of distributing, so I'm dividing that 3 out of each term. So when I divide 3x squared by 3, it would just become x squared. Negative 3x divided by 3, it would just become negative x. And then negative 36 divided by 3 would become negative 12. Okay, and then now I no longer need this part. These are the same exact thing. I've just begun the factoring process. So same value, not same exact thing. The same value, I've just begun the factoring process. Okay, and then now I can begin to factor my trinomials. So like the x squared minus x minus 12, and then the x squared plus 12x plus 27. So one thing I'm going to do is I'm going to bring this 3 over first just so I don't forget it, because that 3 always has to stay out in front unless I'm able to cancel it out with something. And then this trinomial, the one in the numerator, the lead coefficient is 1. So I just need numbers that, if one of the lead coefficient is 1, and when I say lead coefficient, I'm referring to standard form, which is ax squared plus bx plus c. The lead coefficient is whatever a is. So when that's the case, I just need numbers that multiply to c and add up to b. So I would have to find two numbers that multiply to, and that's a multiplication symbol, not an x, multiply to negative 12, but add up to negative 1. So multiply to negative 12, add up to negative 1. we would have to use -4 and +3. So remember, if you're multiplying to a negative number, one number has to be positive, one number has to be negative, and then to get our sum of -1, we'd make the bigger number negative. Okay, so once we have those two numbers, then we can start to create our two binomials that our trinomial factors into. So whenever this first number, lead coefficient, is 1, then it's going to be x and x. It's going to break down in x and x. And then these two numbers are what fill in the rest. So one would be a -4 and one would be a +3. And the order doesn't matter. So I could have put the +3 first and the -4 second. Okay, so same thing on the other side. So let's see, lead coefficient, or not other side, but same thing in the denominator. Lead coefficient is 1, so I just need numbers that multiply, in this case, to 27 and add up to 12. So multiply to 27, that's not a 27, multiply to 27, add up to 12, looks like I would do 3 and 9, and there should only be one correct combination. There shouldn't be any other ones. If you feel like there's multiple, there's probably some sort of like sign issue, so just be careful with that. There should only be one that works. So 3 and 9, 3 times 9 is 27, 3 plus 9 is 12. There was no like GCF that we factored right here, so I should not have a number where that 3 is in the denominator. And then I can set up my parentheses. The x squared breaks down into x, and then these numbers are what fill in the rest. So they're both positive, so one would be a +3 and one would be a +9. And then now it's factored completely so I can see what factors are in common, and they both have an x plus 3. So because they both have a factor of x plus 3, then I can wipe out the entire factor. So the x plus 3 and the x plus 3 cancel each other out completely. I'm not just doing like x and 3 and 3. It's the whole piece that wipes out with the other whole piece because they're factors. They're something that's being multiplied. So the whole thing. Okay, so there's no other common factors. And one thing I'm going to add there is, in order for them to be canceled out, there needs to be one in the numerator and one in the denominator. It would not work if they were both in the same kind of location, like both in the numerator or both in the denominator. It has to be 1 and 1. So in the numerator, I have 3 times x minus 4. And then in the denominator left over, I have that x plus 9. I don't really need the parentheses around that one because I don't have anything else being multiplied by it. And then nothing else can cancel it out again because like at this point now, like this whole factor is an x plus 9. It would need another whole x plus 9 to cancel out, so I can't just do like x and x because those are individual terms. Okay, so final answer, 3 times x minus 4 over x plus 9. I don't have a personal preference if you distribute that 3 in or not. Just know that like depending on what kind of question you're looking at, if it's multiple choice, check to see. If you don't see this answer, see if maybe one of them is just distributed in instead. Okay, so 19.2 is introducing long division. So the long division, it's the same long division as like you learned in, I don't know when you learned long division, maybe 4th grade, but with like polynomials, so with variables and exponents and all that stuff. But the gist of it is almost exactly the same. Okay, so before I start this, these are like these problems specifically, like long division, are usually ones that you maybe want to watch like once or twice through. So like don't feel any sort of way if you need to like go back in the video and just kind of rewatch it, or like maybe watch it one time through first before you begin writing down and then write it on the second time through. Okay, so 19.2, example number 1, divide 3x to the 4th plus 5x cubed plus x plus 1 by x squared. So with long division, we do like that great big long kind of division bar. So one thing that we have to be careful about, so what we're dividing into, that goes inside. So this whole thing will go inside, but you have to be really careful. So if you ever skip a power of x or a constant, you have to put in a 0 as a placeholder. So like we go from 4 to 3 and then we go to the first power. So I would have to put a placeholder in between those two. I'll put a 0 x squared, since there's no x squared term, you would also have to put a 0 at the end if there was no constant. So basically whatever the highest power is, you have to count down until you get to the constant. So you do x to the fourth, x to the third, x to the second, x to the first, and then your constant term, the one that doesn't have the variable. If you're missing any of those, then you need to add a 0 in there. You would never need to go up by a power. So I would never have to like put in an x to the fifth or anything like that. Okay, so inside my division bar would be 3x to the fourth plus 5x cubed, and then plus that 0x squared. So 0x squared is still 0. It's just a placeholder for where x squared would be. And then plus x plus 1. And then I'm dividing that by x squared, so that's what goes out here. So when you're using log division, we kind of just focus on 2 terms at a time, at least when we're dividing by a monomial, which is just the one term. And we just focus on one term from each part of the problem. And then we kind of like are able to work our way down until we get to the end. That maybe doesn't make a whole lot of sense right now, but hopefully it does after this. Okay, so what we do is we start with the first term inside the division bar. So we do 3x to the fourth divided by x squared. So you divide the coefficients. So this coefficient of 1. So 3 divided by 1 is 3, and then we can divide the x's, x to the fourth divided by x squared. Remember that when you divide powers, you subtract the exponents. So x to the fourth divided by x squared would be x squared. Okay, this next part is like not mandatory, but I think it's really helpful to keeping your work neat. So 3x to the fourth divided by x squared is 3x squared. I like to just line it up with my other x squared terms. I feel like it just helps keep things a lot more organized. So one more time, I'm going to go through that real quick now that it's there and we can kind of see it. So we do 3 divided by 1, which is 3. And then x to the fourth divided by x squared, you do 4 minus 2 is 2, so there's an x squared left over. Okay, and then we got that new number on top of the fraction bar, so the next, not fraction bar, division, the next step is to take that 3x squared and multiply it by x squared. So we would do 3x squared by x squared, which is 3x to the fourth. So I put that 3x to the fourth down there, and you're like, okay, it's the same thing. It's supposed to be the same exact thing. It should always be the same exact thing. At least when you multiply the first term in, we're going to get into like dividing by binomials. In that case, it's a little bit different, but this should always be the same. Because the next step on division is subtracting, so we would subtract this, and the goal is to cancel it out. So it cancels out, and then we move on to the next term. So you don't necessarily have to do this if you're just dividing by one, like a monomial like x squared, but this is like kind of what the process is going to look like as the problems get a little bit harder. So I want to keep it looking almost exactly the same every single time. So we've subtracted 3x to the fourth minus 3x to the fourth, that's 0. So then next I bring down my next term, 5x cubed, and that becomes what I divide by x squared. So I do 5x cubed divided by x squared, which is 5x. And then I got my new term up here, so I take that new term and I multiply it by my x squared. So 5x times x squared is 5x cubed. And then now I can go ahead and subtract. So 5x cubed minus 5x cubed, that is 0. That cancels out, that's exactly what we're trying to do. And then I can bring down my next term. So 0x squared. And then next I can take my 0x squared divided by 1x squared. That's just 0. But if I do x divided by x, or sorry, x squared divided by x squared, that would go down to my like constant term. So this would just end up being a 0. And then we have that new number up top, which is 0. This problem's a little bit funky with the 0, so just kind of bear with me. We take that 0, we multiply it back through, so 0 times x squared. Still 0x squared. And then we can subtract. It should always cancel out here once we subtract. Again, I know there's just zeros, so sorry, this problem's kind of funky, but just bear with me through the next few. So 0x squared minus 0x squared cancels out. Okay, so here's the biggie. Once you get to the constant term, which I know this is 0, but that's where the constant term should be because we went like x squared, x to the first power, and then the next one would be the constant, which is then without the variable. Then you're done. And the rest of the problem ends up being your remainder. So, like, we have left over right here, I have an x plus 1. You can write it brought down, or you can just leave it up there. As long as you recognize that this part is going to be your remainder. And I don't know if you remember from like way, way, way back when, but the way that you write your remainder is, in this case, the whole thing, x plus 1. And then even like when you first learn long division with regular numbers, you write your remainder as like the remainder over what you divided by. So in this case, it would be x plus 1 over x squared. And then, because we divided by x squared. And then for your final answer, you don't need to include the actual placeholder. It just, things get a little bit funky when we don't have it there, especially when we're dividing by more than one term. So for our final answer, it'd be 3x squared and then plus 5x and then plus our remainder x plus 1 over x squared. Kind of a good way to like check your work, or like something that you could at least look out for is your remainder should never have a power of x that's the same or more than the denominator. So like this is an x to the first power, this is an x squared. So the denominator, sorry, the power in the numerator must be smaller than the power in the denominator for the remainder. So 3x squared plus 5x plus x plus 1 over x squared. Okay, and then number 2, divide 2x cubed minus, 2x cubed plus 4x squared minus 5x plus 3 by 2x. Okay, so similar problem, we just have a coefficient now. So we'll set it up the same way. This one, like if we look at our highest power, it's 3. I don't need to like add a placeholder for x to the fourth because I never have to like go up by a power. I just have to make sure that I go 3, 2, 1, and then the constant. So we have that, so I don't need to put any zeros in for this one, so that's kind of nice. Okay, so inside will be a 2x cubed, this whole thing, 2x cubed plus 4x squared minus 5x plus 3, and then we're dividing by 2x, so that goes on the outside left. Okay, so I start with my first term, so I do 2x cubed divided by 2x. So first I would divide the coefficients. 2 divided by 2 is 1, and then x cubed divided by x is x squared. So 2x cubed divided by 2x is just a 1x. And again, I like to line it up over the other 1x's. It just helps you keep your work more organized. Okay, one more time, I'm just going to go through that really quickly now that we can kind of see the result. So 2 divided by 2 is a 1, so the coefficient is 1, but we don't write it. And then x cubed divided by, oh no, yeah, see, this is why you go back and check it, because there was a mistake there. That should have been an x squared. Move that over there, and then let me go through it one more time, just because that was kind of meh. Okay, so 2 divided by 2 is 1, so the coefficient is 1, but we don't need to write it. And then x cubed divided by an x to the first power. X cubed divided by x to the first power, you can do 3 minus 1. That leaves you with x squared. Okay, and then now that we've placed a new number on top, we take that new number and we multiply it back through here. So we would do, not number, but term. So we do x squared times 2x, which is 2x cubed. And these should always be the same because you're trying to cancel out that first term to move down to the next one. So we would subtract 2x cubed minus 2x cubed is 0. That cancels it out. And then I move down to the next term. So I bring down my 4x squared. And that becomes the new thing that I'm dividing into. So I do 4x squared divided by 2x. So 4 divided by 2 is a positive 2, and then x squared divided by x leaves me with an x to the first power. So one more time, 4 divided by 2 is 2, and then x squared divided by x is x to the first power. And then I just put a new term up top, so I'm going to take that new term, and notice I'm just only multiplying like the new one by it. I'm not doing both. So I do 2x times 2x, which is 4x squared. So the 4x squared goes down here. And then now I'm subtracting with the goal to cancel out that term. 4x squared minus 4x squared is 0, so that cancels out, which means I'm doing everything right. If it doesn't cancel out, if it's not the same term, something is wrong. Okay, I can bring down my next term. That's a whole like negative 5x. So that new term that I just brought down becomes what I'm dividing into. So I do negative 5x divided by negative 2. Well, negative 5 divided by 2 is negative 5 halves. And then x divided by x cancels out, so I don't have any more x's. So one more time, negative 5 divided by 2 is negative 5 halves. X divided by x is 1, so it cancels out the x's. Okay, and then I just got a new number up top there, so I'm going to take that number and multiply it back through. Negative 5 halves times negative 2 is, sorry, negative 5 halves times 2x is negative 5x. Notice that x got multiplied back in. And then here I'm subtracting. I'm going to keep that same color going. So negative 5 halves times 2x is negative 5x. And then here I'm subtracting that lower line. So this is a like negative 5 minus negative 5. Anything minus itself cancels out. You could also think of it as like negative 5. And then this double negative turns into a plus. So negative 5 plus 5 is 0. Either way, whatever works for you, this should cancel out, and it does. And then after that, we have our constant term up here. Like that's the term that just has no variable. Once you've gotten to that term, everything left over that we haven't divided into yet becomes a part of the remainder. So this plus 3. And if you want to kind of like continue the trend and bring down the 3, and even if we were to try like the same process and say, okay, now I take 3 and I divide it by 2x, we can't really do that because we don't have a power of x, but that is how we write our remainder. So we would do plus 3, the remainder, over or divided by 2x. Okay, so final answer, x squared plus 2x minus 5 halves, and then plus our remainder, 3 over 2x. Okay, so last section, 19.3, long division with a binomial. So example, well, there's just one example for this, and then I kind of want to show you an alternative way. The alternative way does not, I personally think it's easier, but it doesn't work for every problem. So the method that we're going to use first is long division, and it does work for every single problem. So example 1, divide 4x to the fourth plus 2x squared minus 1 by x minus 2. So always check to make sure you're not missing any powers. So we're starting at x to the fourth. I don't need to add any like greater powers like x to the fifth, but I go from 4 down to 2. So I would have to put in a 0 x to the third power. And then after x squared, I should have an x to the first power before my constant. So I'd also have to put in a 0 x to the first power. And then there's my constant at the end. So when we're setting up our problem, so 4x to the fourth, and then I skip x cubed, so I'd have to do a 0x cubed. And then next would be my 2x squared, and then I skip that 0x, so I'd have to put that in there. And then next is my minus 1. So 4x to the, 4x to the fourth 4x to the fourth plus 0x cubed, so right here, plus 2x squared plus 0x right here, and then minus 1 right there. So if you ever like start your problem, and okay, if you feel like you're doing everything correct in your problem and you just hit a wall and something looks weird, make sure you go back and double check that you have zeros in for any powers of x that you may have missed. And that also goes for what we're dividing by also. So for example, don't write this because I'm not going to leave the problem this way, but if this was like an x squared, then over here, I would have to put x squared plus 0x to the first power and then the constant minus 2. Okay, so it goes both ways. Anytime you're missing a like power of x, you have to include it. Okay, so we're dividing by x minus 2, so that'll go here. And then this is where like kind of what I was saying about like we're always just focusing on the first part of each polynomial comes in. So what I mean by that is we're going to start with the first term here and divide it by the first term here. I'm actually always going to be dividing by x. The 2 just kind of like carries along and it just works out. So I would do 4x to the fourth divided by x, which is, this is like a 1x. So it'd be 4x cubed would be my quotient. So 4x cubed. So I'm getting that from 4 divided by 1 is 4, and then x to the fourth divided by x is x cubed. And then now that I have a new term up at the top, I'm going to take that new term and I'm going to multiply it by this whole thing. So that's where the 2 comes in. I got to multiply it by the whole thing. So I'm going to do 4x cubed times x, so that's 4x to the fourth, and then next I would do 4x cubed times negative 2. So 4x cubed times negative 2 is negative 8x cubed. You only need the first ones to be the same. We only need we only have to cancel out that first term and move down to the next one. Okay, so now that we have it like multiplied it back through, now we're going to subtract. I recommend putting parentheses around this so that you remember to subtract each term because it can be really easy to forget that. So 4x to the fourth minus 4x to the fourth is 0. So this cancels out and you always want the first one to cancel out. And then here's where we got to be careful with like the subtraction and stuff like that because this is 0. So x cubed, like we're just adding or subtracting like terms. The x cubed part is going to stay the same. It's the coefficient that we have to worry about. So this is 0, 0, and then minus negative 8. So 0 minus negative 8, if you do like a double negative 0 minus negative 8, a double negative turns into a positive. So this would actually be a positive 8x cubed. So that's why I like to use parentheses so we don't like miss that or kind of forget about that we're subtracting. So 0 minus 0x cubed minus a negative 8x cubed is a positive 8x cubed. And then after I've subtracted, I bring down one term. So I would bring down the positive or the plus 2x squared. And then I repeat the same exact process over. So now 8x cubed is my new first term. So that's what I'm dividing into now. So I would do 8x cubed divided by x, which is 8x squared. So that goes up here. So one more time through that. 8 divided by 1 is 8, and then x cubed divided by x goes down to x squared. So that's how we get the 8x squared up there. And then now that I have that new term at the top, I take that new term, 8x squared, only that one, not the 4x cubed, and I multiply it by this whole thing. So I would do 8x squared times x, which is 8x cubed. And then I would do 8x squared times negative 2, which is negative 16x squared. And then now I subtract that lower line. So same thing, I like to put parentheses around it just to remind myself. These should be the same because I want something minus itself to cancel out that first term. So 8x cubed minus 8x cubed is 0, so that cancels out. And then this is 2x squared minus a negative 16x squared. So remember, minus the negative turns into a plus, so it's like 2 plus 16, so 18x squared. Notice when I'm adding or subtracting these, the like powers of x stay the same. So 2x squared minus negative 16x squared, 18x squared. And then now we bring down a new term. So we bring down the 0x, so it'd be plus 0x. And then we repeat the process over. So this is my new first term. 18x squared divided by x. So 18 divided by 1 is 18. X squared divided by x is x to the first power. So this was 18 divided by 1 is 18. X squared divided by x is x to the first power. And then now I have a new first term up top. I'm going to take that new term only and multiply it through. So 18x times x is 18x squared. 18x times negative 2 is a negative 36x. And then now that I have that second line, I'm going to go ahead and subtract it. So 18x squared minus 18x squared is 0. That first part should always cancel out. If it's not, go back and look for a little mistake. And then this is 0x minus negative 36. So it's like just 0 minus negative 36. The minus negative again turns into a plus. There's a lot of double negatives in this problem. But 0 minus negative 36 will turn into a positive 36x, with x the first power staying the same. Okay, and then we have one more term to bring down, the negative 1. And notice, like, I'm not stopping. I'm not at the constant term yet, and that's the one without the, like, power, or without the variable. I have to keep going until I get there. So I bring down that 1, and then now my new first term is 36, so I do 36x. So I do 36x divided by x, which is 36. So this would be a plus 36 up here. And then I have my new like term up here that I'm going to multiply throughout here. So 36 times x is 36x. 36 times negative 2 is negative 72. And then now that I have that second line, I'm going to go ahead and subtract it. And notice how every single like time it's been like 2 terms minus 2 terms, 2 terms minus 2 terms, 2 times 2, or 2 minus 2, sorry, and then 2 terms minus 2 terms. That trend should always be true. You're always just subtracting the exact amount of terms that you should have down there. Okay, so 36x minus 36x, 0, cancels out again, as it should. And then this is a negative 1 minus negative 72. So it's like negative 1 plus 72, which is 71. And then I have no more terms to bring down. So another way of telling us that we're done is we don't have any more terms to bring down. So what we have left over, 71, must be my remainder. I can't really divide 71 by x minus 2, so I write it as plus 71 over x minus 2. And if your remainder is like ever, x minus 2, if your remainder is ever negative, you could, depending on how many terms there would be, you might want to write it as minus, or you could just do like plus with the negative number in the numerator of the fraction. That's totally fine as well. Okay, so final answer altogether, it's a long one, 4x cubed plus 8x squared plus 18x plus 36, and then plus the remainder 71 over what we divided by over x minus 2. Okay, so there is one more way to do problems like this. Sorry, that was very dramatic. But if you're like, no, I'm good with long division, this is how I want to do every problem, you can probably stop the video here. If you want to learn a little bit faster way that works for a lot of these problems, just keep going. Okay, so the other way is called synthetic division, and it's only when you're dividing by something in the form x minus k Okay, so it only works for certain problems. It would work for this problem, so we're going to use the same exact one. So we're going to take this same thing and just do it over here with synthetic. So I want to first give you examples of like, because the x minus k thing is kind of new. So if you, like an example of something that would not be in that form would be like x squared minus or plus any number, I don't know, 4, because it has x squared. Like it needs to just have x the first power. Another example of something that wouldn't work would be like a 4x plus 9 or something, because it's 4x. So it needs to be just like 1x to the first power to work, which is a lot of the problems. So some of them, no, it doesn't work, but it is a lot of the problems, trust me. So it is kind of worth like learning and spending time on it. So these are counter examples, can't use it there, but we are dividing by x minus 2. So that is definitely in the form x minus k. So I'm just going to rewrite this over here really quick. So 4x to the fourth plus 2x squared minus 1, and then divided by x minus 2. Okay, so the way that we set up for synthetic is you kind of create this big open box, maybe like kind of like an upside down division bar type of thing. And then k, whatever value k is going to go over here. So what that means is that we're dividing by something in the form x minus k. So we look at what we're dividing by and we're like, okay, what is k? Well, there's a minus there. So it's kind of one of those things where it's like the opposite of what it looks like it should be. So since there's a minus there and it's x minus 2, k would just be like regular 2, positive 2. So we put a 2 right here. And then the coefficients of what we're dividing into go inside the box across the top. And it's the same thing here. If you're missing powers of x, you have to include it. So like this is a 4, that's my first coefficient. And then I'm missing the like x cubed, so it'd be 0x cubed. So I'd put a 0 next. And then my next coefficient would be 2. And then I'm missing next the first power, so it'd be like a 0x, so I'd put a 0 where x the first power would be. And then the last one is the constant -1, so that the number just goes right here. So this is from like my, I'm gonna write it pretty small right above it. This is my 4x to the fourth, 0x cubed, 2x squared, 0x, and then -1. So I'm just putting just the coefficients, just the numbers in front of like the x's and the constant in the box. Okay, so the first step always, and it's easy to forget this, so just maybe make yourself like a note to try to remember. First step is just always bring the first number down. So we bring down the 4, and then we're going to take that 4 and we're going to multiply it by this 2. So do 4 times 2. That number goes here next in the box. And then we add the columns. So it's different than long division. Like long division, you're used to getting the next number and subtracting. Here we add. So we do 0 plus 8, which is 8. And then I take that new number and I multiply it by my k. So I do 8 times 2, which is 16. Put that new number there. And then I'm adding. So I would do 16, or 2 plus 16 is 18. And then I'm taking that number and I'm multiplying it by that 2 over there. So 18 times 2, 36. And then adding that new column that just got filled in, 0 plus 36 is 36. And then I take that 36 and I multiply it by the 2, which is 72. And then I add this last column, -1 plus 72 is 71. And then we're almost to the final answer. This part's also super important and can be easily forgotten. So all these numbers right here are the coefficients of our final answer. Most of the time, whenever we do stuff, we start on the left side. You got to start on the right side here. Like you just have to, or else it's going to be so easy to make a mistake. So starting on the right side, this is our remainder. and then the next number over is our constant, and then the next number over is our coefficient of x to the first power. Next number is x squared, and then the next number is x cubed. So always start on the right with the remainder, and then go constant x to the first power, x squared, x cubed. So then we write our final answer. It'll be a 4x cubed plus 8x squared plus 18 x to the first power plus 36. And then for our remainder, it's a positive 71, so we do plus 71, and then it still goes over what we divided by, which was x minus 2. So over x minus 2, so 4x cubed plus 8x squared plus 18x plus 36 plus 71 over x minus 2, and it's the same answer we got for the other way. So you can decide which one you use. Just know that like synthetic only works for certain problems, but it really is like a lot more of an efficient way to do it. So that's why it's worth knowing how to do both ways. Okay, so before I stop, I know that these problems, like, if there's a lot of movement, there's a lot going on. So again, if you need to rewatch it, or just like if you YouTube, like if you want to watch a different video, want to hear somebody else talking about it, just YouTube the topic. So like do long division by a binomial, or you can just do like search the entire like title up here, dividing polynomials, and you can say like long division, or if you want another example of synthetic, you can search synthetic division. There will be a million different examples that can help.